Suppose that a typical graduate student at the Delhi School of Economics lives in a two-good world, books and movies. Okay, so books is X, quantity of books is denoted as X, quantity of movies is denoted as Y, and the utility function is X to the power 1 by 5, Y to the power 4 by 5. Price per unit of books is 50 and price per unit of movies is 10. Suppose the university is considering the following schemes. Scheme one is that you will pay the university will pay the student 750 as fellowship and 250 as book grant. Okay, and the book grant can only be spent on books, of course. And the other scheme that the university is considering is the university can pay the student 1,000 as scholarship, and also just to incentivize students to buy books, university is considering this proposal that it will give one movie free on every book the student is going to purchase. Okay, so we have to figure out the optimal consumption bundle of the student under scheme 1 and under scheme 2. Okay, so let us do this problem. In any problem, there are two steps. Basically, first step is to set it up as a maximization or an optimization problem, and the second step is solving it. Okay, and we'll be working on both in this class. Uh, how to set up the problem and then how to solve it. Okay, so let us look at the scheme 1 first. Okay, so in scheme 1, 750 is paid as fellowship. Okay, so 750 is the fellowship amount and 250 is the book grant. Now the thing is that fellowship amount can also be spent on books. So there is no restriction on the fellowship amount. Okay, but there is a restriction on the book grant. Book grant can only be spent on books. Fellowship amount can be spent on books, movies, whatever the student wants, but the book grant can only be spent on books. So you just have to keep these things in mind, okay, while setting up the problem. So let us think about it, like how we're going to set it up. Okay, so obviously the objective of the student will be to maximize his utility. So he's going to maximize x to the power 1 by 5 into y to the power 4 by 5. Okay, with respect to x and y. Okay, subject to the constraints. So now first let's write the expenditure constraint. Okay, that expenditure cannot exceed the total amount of money that the student is getting. So expenditure on what? Expenditure on books and movies. So how much is the total expenditure on books and movies if he consumes x books and y movies? It is 50x plus 10y. So 50x plus 10y, that's the total expenditure on books and movies. Cannot be more than the total amount that the student gets. Okay, and then there is another constraint that the amount spent on movies cannot be more than 750. Okay, the amount spent on movies cannot be more than 750 because you cannot buy movie with the book grant. Okay, is that clear? So if you want to find the optimal consumption bundle under scheme 1, this is the problem that you need to solve. Yes or no? Now it is all about plotting and solving the problem properly. Okay, so let us do that. Okay, so if we plot this, this is how it's going to look. If we plot the constraint, okay, this is the first constraint. This is the boundary of the first constraint. And what about the second constraint? The second constraint is that y should be less than or equal to 75, right? I mean, I can rewrite this as y less than or equal to 75. So I'll get this horizontal line like this, which says that y has to be less than or equal to 75. So basically, the constraint set, the set of set of points that satisfy both these constraints are given by this region. Okay, and what is this point? This is 75. Okay, so if you plug in 75 here, you will get 750. So so x will be 5. So this is actually 5. Okay, this point is 575. Okay, now we have to figure out, where in this region is this expression maximized. Okay, that is what we need to figure it out. Okay, so how do we do that? Well, it's the standard procedure. You just have to check. You just have to check. Whether the highest possible indifference curve passes through this point or not, or this point, or where is it basically? Where is the highest possible indifference curve? If you try and plot this indifference map, where is the highest possible indifference curve? So for that, you need to figure out what is the marginal rate of substitution. Okay, so let us figure out the marginal rate of substitution. Marginal rate of substitution is marginal utility of x, which is the partial derivative of utility with respect to x, and you will get what? 1 by 5 y to the power 4 by 5 divided by x to the power 4 by 5, right? Yes. And what is marginal utility of y? It is 4 by 5. Okay, x to the power 1 by 5 upon y to the power 1 by 5, right? And you're gonna get what? 1 by 4 y by x. So that's the marginal rate of substitution. Is that okay? And notice that this is diminishing. As x increases, as we move along the indifference curve, indifference curves are going to be downward sloping because both are goods. As x increases, the satisfaction level goes up. As y increases, the satisfaction level goes up. So if you want to be on a particular indifference curve, then if you try to increase x, you have to reduce y to make sure that the utility is kept at the same level. So the indifference curve is going to be downward sloping. And the other thing is that the margin rate of substitution, if you look at this particular expression, as x increases, the y goes down. So this term, comes down as x increases, right? So basically, the indifference curve will look like this, will have this shape. Okay, now you just have to figure out, what is the optimal indifference curve? Basically, what is the highest possible indifference curve that passes through the constraint set? Okay, so that is what we need to figure out. Okay, so how do we do that? Well, one thing that we can do is maybe we can check here. How is the indifference curve going to look? How is that indifference curve going to look? The one that passes through this point. Is it going to look like this, or is it going to look like this? If we can just figure that out, it can actually help us figure out where the optimal choice is. Where is the optimal choice in this region? Okay, so notice that if it is going to look like this, then this point is not the optimal point. Then in that case, the optimal choice will be somewhere here. But if it is going to look like this, then in that case, this will be the optimal point. Okay, the reason is because it's the highest indifference curve passing through this region. Now, if you go to any other point, you'll always be on a lower indifference curve. So we need to figure out whether the indifference curve looks like this, looks like this, or it looks like this. That is what we need to figure out. Okay, so let us do that. Let us check, at this point, how is the indifference curve going to look? Whether it is going to be flatter or it's steeper. Okay, so flatter or steeper compared to this line, basically. This is the line that we are going to compare it with. Okay, what is the absolute value of the slope of this line? Okay, let's just check that out. What is the absolute value of the slope of this line? It is 5, right? Okay, and what is the slope of the indifference curve at this point? So we need to figure out what is the absolute value of the slope of IC at this point. That is what we need to check. So, and what is the absolute value of the slope of the IC? It is the MRS, right? So what is the MRS at this point? What is the marginal rate of substitution at this point? Okay, so this is y by x, y by 4x, right? So y is 75. Okay, x is 5, so 4 into 5, which is 75 by 20. Okay, which is going to give you what? 3 0.75, right? Just check. Yes or no?
Yes, sir.
Okay, so what is the slope of the indifference curve at this point in absolute terms? It is 3.75. And do you agree it's less than the slope of the budget line at this? I mean, if you just compare this portion of the budget line, it is steeper than the indifference curve at this point. So what that means is, if you try and draw the indifference curve, it will be flatter. It will look like this. If I try and draw the indifference curve over here, it will be flatter like this. Yes or no? Okay, so since it is flatter, that means this is the optimal choice. Okay, this is the optimal choice. That means 5 comma 75 is the optimal choice. And this is, again, this is something that you can also, there is an economic interpretation of this as well. I mean, if you see MRS is 3.75, which means MUX by MUY is 3.75. Okay, and if you see on this line, PX by PY is 5, right? PX by PY is 5. Okay, and MUX by MUY is actually less than PX by PY, at this point. So if I rewrite this inequality, I can write it like this, that at this point MUX by PX is less than MUY by PY. So what that means is, you would love to move your money from X to Y, if possible. If possible, you would want to move money from books to movies. So you would want to buy more of movies and less of books if you are at this point. The problem is that you cannot do that. The reason is that this 250 is for the book grant. So you have already spent 750 on movies over here, and you would still want to move your money from movies, from books to movies, but you cannot do that. The reason is that this 250 is for the books. You cannot spend part of this money on movies, right? I mean, that's not possible. So you will stop here. So while you would be interested in moving your money from books to movies, but because you have already exhausted your budget, you are already exhausted your fellowship on movies, you cannot do that further. You cannot take money out of the book grant and put it in the movies. That is not possible. And since that's not possible, so you'll stop here and you'll buy exactly 750 worth of movies and 250 worth of books. Okay, while you would love to, you would, if you are allowed, let's say if the budget line would have been like this, you would love to move your money from out of this 250, you would have spent, you would have loved to spend part of it on movies, but you cannot. The reason is because you cannot go in this direction. Okay, that's the economic intuition, and you know that's why the solution is 575. Okay, so let us do the next part, you know, which is, you know, if you the scheme 2. Okay, so scheme 2 says the following, that you know you will get 1,000 as scholarship. Okay, okay, and you will get one movie free on every book you purchase. Okay, so you will get one movie free with every book you purchase. And please note that because books and movies are perfectly divisible here, you know, you know, we are assuming that books and movies are perfectly divisible. So it is possible that, you know, we can consume books and movies in non-integer quantities. Okay, so what does this constraint, what does this scheme means in that case? So in case you buy half a book, then you will get half a movie free. So when you say that one movie free with every book you purchase, that means that, you know, if you buy half a movie, then half a book, then you'll get half a movie free. Okay, so we are assuming that, you know, so if you buy X number of books, then you'll get X number of movies free with it. Is that clear? This X can take any value. It doesn't necessarily have to take an integer value. It can take any value. Is that clear? That's what this means, that books and movies are perfectly divisible. Is that okay? Okay, so let us write this optimization problem where you have, you know, this kind of scheme. Okay, so again, you know, the student would want to maximize utility. Okay, and notice that X here is the books amount of books consumed, and Y is the number of movies consumed. Okay, X is the number of books consumed, Y is the number of movies consumed. Okay, so the first is your budget constraint, which says that expenditure cannot exceed 1,000. You know, so your expenditure on books and movies cannot exceed 1,000. So what is your expenditure on books and movies? So notice that, what are you buying? You are buying X units of books because you're consuming X units of books. So if you're consuming X units of books, so you'll have to buy X units of books, right? So 50X is the expenditure on books, plus how much is the expenditure on movies? Now, if you are consuming Y units of movies, if you are consuming Y units of movies, your expenditure on movies is not 10Y. Okay, it is 10 times Y minus X. Why is that so? Because out of Y movies that you're consuming, X movies are free because you bought X books. Since you bought X books, so you got X movies free with them. So it is only the difference between Y and X that you have to pay for, right? Yes or no? It is the difference between Y and X. These are the number of movies that you need to pay for. You don't have to pay for all Y movies that you're consuming. You just need to pay for Y minus X of them. Yes or no? Okay. And this expenditure cannot be more than 1,000. Okay. And the next constraint is, of course, you know, the number of movies that you consume has to be at least equal to the number of books that you consume. The reason is because you will definitely get X movies free with X books. So you will definitely be consuming at least as many movies, at least, you know, the number of movies that you'll consume will be at least equal to the number of books. The reason is because, you know, you'll get these many movies free with these many books, right? So you'll definitely be consuming these many movies, you know, and maybe more, you know, and that depends on this. Okay, this problem. Is that okay? Have you all understood this? Okay, and now it's just again, you know, the straightforward problem. You just have to plot the constraint, and then just a routine thing, you know, I mean, just plot these two constraints and solve the problem. Okay, so notice that this first constraint, can be rewritten as 40x plus 10y less than or equal to 100. Okay, it's 1000. Okay, so this first constraint can be rewritten like this. So what I'll do is I'll draw a line like this. Okay, and this is 1000. Sorry, this is 100. Okay, and this is 25. Okay, which is basically this boundary of this constraint. Okay, and then y is greater than or equal to x. So if I draw a 45-degree line like this, you know, y is equal to x is this. Okay, y is greater than or equal to x is this. Okay, so basically, you know, if you see, this is your budget constraint, and this is the second part of the budget constraint. So you know, it is basically the region in, you know, which is enclosed by this triangle, right? Because y greater than or equal to x will give you this region, and this will give you this region. So the intersection is basically this region. Yes. Okay, and I can erase the remaining. Okay, and now again I'm just going to do the same steps. You know, I mean, I'm going to check whether this point is a solution or not. So if the indifference curve looks like this, then this point is not the solution. If the indifference curve looks like this, then this point is the solution. So I just have to check whether this point is a solution or not. If this point is a solution, then I'm done. If this is not the solution, then solution will be somewhere here. Because if this is not the solution, then in that case, the solution will be somewhere here. So I need to check whether it is going to be like this or it is going to be like this. So whatever, you know, whichever the case is, I need to figure that out first. Okay, so let's just do that. So what is the MRS? So if you remember, MRS is y by 4x. Okay, and at this point, you know, because this point lies on y equal to x line. Okay, so at this point, the MRS is 0.25. So at this point, MRS is 1 by 4, right? Because y equals to x at this point. So at this point, MRS is 1 by 4. And what is the slope of this in absolute terms? It is 4, right? Yes or no? And this tells you that if I draw the indifference curve at this point, it will be flatter than this line. So it will look like this. Yes or no? If I draw the indifference curve through this point, it will be flatter than this line. So it will look like this, which means that the optimal choice will lie somewhere over here. So I need to figure out this point. Okay, so how do I figure out this point? Well, at this point, it must be the case that MRS must be equal to the absolute value of the slope of this line. Okay, so which means that at this point, what is the MRS? Y by 4x. So y by 4x. So at this point, okay, at this point, y by 4x must be equal to the slope of this line, you know, the boundary of this constraint basically, which is 4, which means y must be equal to 16x. And second thing that is true about this point is that this point lies on this line, okay, which is basically 40x plus 10y equal to 1000. So we have two equations, two unknowns, and we can solve for x and y, right? I mean, to get this point. Okay, so let's solve it. So we'll get what? 40x plus 160y, 160x, 40x plus 160x is equal to 1000, which is going to give you x equal to 5. Okay, and once you know that x is 5, you get y equals to 80. Please note that this is the consumption of movies. Okay, he's going to consume 80 movies and 5 books, you know, and out of these 80 movies, 5 movies are you know, something that he's going to get for free, you know, because he has purchased 5 books, so he's going to get 1 movie free with each book. So 5 movies are free, so he's going to purchase 75 movies, and 5 movies are going to be free, and 5 books, so he's going to consume 5 books and 80 movies.